Welcome back to CS201 Walkthroughs. My name is Lukash, and today I want to go over the practice midterm. But I don't just want to talk about the answers. Instead, I'm going to try to take this practice midterm. I haven't looked at it before, and I'm going to go through the problems, how I would think about them, undoubtedly make a number of very embarrassing mistakes that someone will kindly point out in the comments, and then maybe I'll add them in the video description so that you can go through and check that what you're seeing is accurate or understand what the actual response should be. All I have is the practice midterm pulled up on my computer. I'm going to go through the problems, try to explain my thinking a little bit. Hopefully I don't get too many of them wrong. Again, check the comments or check the notes below this video to make sure that what you're watching, if it seems a little strange, is not completely inaccurate. Without anything else, I guess I'll get started. The first problem here is 1A. It says, define a racket procedure, change item 1, item 2 list. That changes every top-level occurrence of item 1 in list to item 2. Okay, that makes some sense, right? Item 1 goes to item 2. Use only these built-in racket procedures. I don't plan on using anything else. Do not write auxiliary procedures, and then let's just take one of their examples, something like change. I'll try to move out of the way. A, B, A, 1A, S, A, and D. And this returns, that's alas, yeah. This returns B, L, B, S, and then in list. So B, L, B, S, A, and D. And my job is to write the racket procedure that turns this into this. Okay, so this seems like a pretty simple list recursion problem to me. I'm just going to go through, check if the element, remember it's top level element, so this A here is not converted to a B. It's not a top level element. This list with A and D inside of it is the top level element. So I'll check if each one in here is equal to a B, or is equal to an A. If so, I'll change it to a B. Also, I'll just cons it into my output. I'm probably going to be doing this non-tail recursively, just because it says you can't write helper procedures, and I don't see a place in here that I could store the new list I'm making. So let's go. Define, change, item 1, item 2, list. Okay. My base case I have to write first. I'm going to write if empty list, and of course return the empty list. And my else is going to be another if, checking whether the car of this is what I'm looking for. So I'll say something like if equal car list to, what's it called, item 1. And if that is true, I'm going to output item 2. And else, I'm not just going to output item 2. I need to put my recursive call here, so instead I'm going to cons item 2 to my recursive call, which is change on item 1 and item 2 stay the same. It would be convenient if I was standing on the other side, but maybe I'll just make sure I move out of the way at the end. But I'm going to code the list. Right, so I'm removing that first element from the list. If it was item 1, I'm replacing it with item 2. Also, I'm just going to leave it alone. Cons car list onto change item 1, item 2, CDR list. Now I got to close my parentheses. Here I'm going to close my change, close my cons, close my if, close my other if, close my define. Okay. I think this procedure should work. If not, be a little bit worried. But the idea there was I saw this as a list recursion problem where I'm just replacing top level elements. I don't need to go deep into any elements, so it's not a tree recursion problem. And I just need to check in each individual element to see if it should be replaced. So that's a simple if, asking if equal car list to the item, replace it with item 2, else cons that car list, or whatever it is, into the rest of the list, which eventually returns empty list when my input list becomes empty. Okay, let's move on. 1b says to draw a tree of recursive calls with return values. For this procedure, when evaluating change 3, 8, okay, let me write the call over here. Change 3, 8, and then it's a list 1, 3, 4, 3. List 1, 3, 4, 3. Okay, great. So we know it's just going to cutter its way through the list. So here it's going to say it's not empty, and it's going to keep being not empty until it reaches the end. So I'll do something like this. This calls change on 3, 8. This calls cons 1 onto change 3, 8, list 3, 4, 3, which calls cons 3, oh, just kidding, cons 8 because it gets replaced, onto change 3, 8, list 4, 3. This calls cons 4 onto change 3, 8, list 3. Oh, I'm missing some parentheses, aren't I? This guy calls cons 8 onto change 3, 8, empty list, which will just return empty list. Okay, so I think here I have, I guess, like the return, maybe I have to add in the return values, so I'll say something like this returns empty list, this guy returns 8 in the list, this guy returns, let's see, cons 4 onto, this cons is 8 onto the empty list, this cons is 4 onto the return of this, so it'll be 4, 8. This guy cons is 8 onto the return of this, so this will return 8, 4, 8. And then this guy will return, this will return to this, 1, 8, 4, 8. Does that seem right? I've replaced all the 3's with 8's, so I think that's right. I don't think there's a specific format in which you have to draw this, but this format works, right? I drew all the calls, and I drew all the return values from those calls. That should be okay. Okay, that's problem 1. Move out of the way, make sure you can see everything. I hope it's not cut off at the end over there. But I'm going to erase and move on to problem 2.